I should actually do a quick thanks to Microsoft Reactor for hosting us tonight, and Peter for organising, and for Cloud Shuttle for providing pizza and drinks, so thank you very much. But also, thanks very much to everyone who's actually in the room tonight, giving up their own time, listening to me babble on about something very, very weird. And the very, very weird thing I wanted to talk to tonight is about Mastodon user behaviour and discovering some unusual insights around distributed user interaction. But don't worry, there's data engineering here. We will be talking about Kafka and DuckDB. So, what am I talking about tonight? I was going to blast through a quick what is Mastodon and what we actually mean when we talk about a decentralized social network and how that actually becomes a bit of a problem when you want to understand user behavior. Then we're going to jump into some distributed data collection with Apache Kafka and Kafka Connect. And then we're going to do some exploratory data analysis using my favorite tool at the moment, DuckDB and some Seaborn libraries. And if Peter allows me to run a bit over time, I'm going to do a quick code demo. So, this is me, principal data engineer with Thoughtworks, Kafka community, Confluent, Catalyst. Right, Mastodon. Who uses Mastodon? 1, 2, 3. Who uses Twitter? Excellent. Okay, at least you've got a bit of a grounding of what we're talking about here. So Mastodon is a decentralized networking platform. This is a bit analogous to when we use email. I might use Yahoo email and might use Gmail. Peter probably hosts his own email server. But what we can all do is we can actually all communicate to one another. And when we're talking about Mastodon users, users actually sign up on a specific instance, and that instance tends to have sort of rules about what behaviour is accepted. Some instances allow swearing, other instances are a bit sort of more freeform. But ultimately, users start communicating on their own server, and then servers can connect to one another, so messages can start flying across servers. And this actually forms what's known as a federated social networking, which just means lots of interconnected servers, which is kind of cool. So what does this actually mean? This means this setup allows for great independent communities to thrive, and people can find communities that sort of work for them. But a bit of a side effect is it's really difficult to get a bit of a sense about what's happening in the world at the moment when you've got tens of thousands of servers. So I wanted to actually start thinking about how would you start solving that. So just a quick intro for what does Mastodon user behavior look like. The other day I was looking at the PyCon website, and you can follow them on Twitter or you can follow them on Mastodon. If you click that link, it takes you to this thing, which is their Mastodon instance for PyCon AU. And there's two things to note here. PyCon AU is the name of the account, but it's the name of the account on a server, which one happens to be fostered on. So there's two things that make up that user account. It's a username on a particular server. Again, it's a bit like an email address. So when I, as a user, want to follow that account, I jump onto my server. Now, I'm actually on a different server. I'm on something called DataFolks. Now, I need to be able to say, I want to follow that account from there. So what I actually have to do is copy that entire string and follow it. And this allows, sorry, I'm going a bit fast. This allows me to follow someone else on another instance. And again, if your mental model is email, you're probably pretty close. But this is how a federated network starts building up. But that leads to a bit of a question. If you've got all of these instances, how do the instances know which messages to send to which other instance? Because this server now needs to know that I'm following an account on that server. And if you think about this from a data engineering perspective, there's a lot of smarts that needs to go on under the covers to make sure that the right messages are being sent to the right server. And it's complicated. This is a simplified diagram of which messages need to get transported from one instance to another instance. I won't take you through all of this, but there's essentially a whole bunch of rules to work out. Does this particular message that someone's written on one server need to get transported to another server? And it's all kind of neat. So, you've got a bit of a mental model of, there's lots of people out there, they're all doing interesting things on different instances, and sometimes these messages start communicating to one another. But if I wanted to take a step back and start thinking, well, what's trending across this entire universe, this actually becomes a non-trivial problem to solve. So, I'm going to take you through the steps of data collection and data visualization across this distributed universe. And this is going to be my architecture. On the left, I've got the data architecture, so I've got a whole bunch of Mastodon instances. In the middle, I've got like a classic data collection platform. I've got Kafka, a schema registry, some serialization in Avro, S3 bucket. And on the right, I'm going to do some exploratory data analysis using DuckDB. So this bit on the left, these are really the independent instances that I'm going to start subscribing to. So I'm going to listen to, and in my case I actually ended up listening to about 60 different instances. So each of these is a separate instance. So I'm listening to Mastodon's social, HackerDB, Universe. So I'm actually running a little Python agent against each of these instances, just so I get a bit of a sense of what's happening in each of the major instances. And this is the Python code under the covers. So this is written in Python, but this is pretty straightforward. So the first thing I'm going to do is write myself a little Kafka producer. So that's just a little thing that connects up to a server and just registers with a particular IP payload. I'm going to build myself a little Avro serializer because I'm actually going to be collecting a lot of data. So using Avro allows me to do this in quite an efficient way. And then I'm going to establish myself a little class that's essentially the listener class for every time a little message is seen on that server. And then I basically say which server am I going to listen to. In this contrived bit of code, I'm listening to Mastodon's social. And that's pretty much it. 20 lines of Python code. I can start listening to the messages on each instance and start barreling it all into a Kafka topic. And this is what it looks like. So I've got 30 or 40 or 50, I can't remember how many of these I was running in the end. Each of them is independent, each of them is listening to the activity on a particular instance, but they're all barreling into exactly the same Kafka topic under the covers. And one kind of neat thing about Mastodon that I discovered is that you don't need to authenticate against each of those servers to work out what the activities that's happening. And in fact, the documentation says, please do not authenticate if you actually want to be just a rogue listener listening to the activity. So you can actually get some rate limiting happening. The docs actually say, please don't authenticate, and then we'll just treat you like an external bot, which is kind of neat. So if you've ever mucked around with the Twitter API, this is kind of neat that you don't actually have to authenticate to find out what's happening. So that's the data collection. So let's move on to the data storage. So in the middle of all of this, I actually wanted to start barreling things into Kafka, which then leads you on to the thought of, well, I've seen how you actually get stuff into Kafka. How are you going to get stuff out of Kafka? And this is such a routine problem in the Kafka universe. There's actually an established framework called Kafka Connect, which makes this really, really straightforward. So my goal is to take the messages from Kafka and put them into Parquet on top of S3. Does anyone know the magic words here? Yes, you're all saying it in unison. Kafka Connect is the way that you do that. So I'm going to use a Kafka Connect S3 sync here, and this is literally the configuration that I need. And again, one of the takeaways here is how straightforward this is. So my goal is to basically come up with a creative connector name. So I'm going to call mine the Mastodon S3 sync. I want to basically use an adapter class. This is a freebie one that's provided by Confluent, which serves this purpose. This is a Kafka topic that I'm subscribing to, and my goal is to write this as Parquet files to disk, and those are essentially all of my S3 secrets. and that's basically just going to barrel down into S3 every 1,000 records or so. And this is neat, and I can scale this up. I can run as many task coordinators as I need, because once this was up and running, this was running several thousand messages every second. So it's kind of neat just to be able to scale this out really quickly. And what this actually means is that when someone sends a Mastodon Toot, that's what they're called, Mastodon Toots. So whenever someone sends a Toot, it goes into a Kafka topic. You can see them flying by with a Kafka visualization tool. And every 1,000 records or so, you get another Parquet file written to S3. So I ran this little agent collecting all of this stuff for a week or so. And this was a very, very straightforward way of just harvesting all of this user behavior and barreling it all into S3, which is pretty straightforward. So, you're thinking to yourself, that was all very, very entertaining, but what am I going to do with the data? And this is where DuckDB comes in. Has anyone heard of DuckDB? Cool. Has anyone used DuckDB? You are my new best friend. I'm managing to use DuckDB quite a lot in my day job, and I just think it's super neat. But in this particular case, I've got a bunch of Parquet files sitting in S3, and because I'm lazy, I just want to get it off S3 and start doing some visualization. And I'm hoping that someone in this room is going to walk out of this door tonight going, DuckDB is going to solve my problem. So what's DuckDB? Why do I need another database? DuckDB is free, it's open source. If you're trying to sort of think about where does it lie on the CAP theory and all of that kind of stuff, it's a relational database, it's SQL, it's OLAP. It's got a really, really extensive, almost like Postgres level of functionality when it comes to SQL, but it's got all of the classic ones about windowing and aggregates and analytic functions and ACID transactions, so it's got all of that good stuff. It's got no external dependencies. It's actually compiled into essentially just one file, and you can use that in process. Under the covers, they've built on the shoulders of giants, so it's actually using Postgres' SQL parser, which is pretty well-rounded. It's got the regular expression engine from Google, and its shell interface is SQLite's shell. So it's actually cobbled together a whole bunch of existing open source technologies. It's got this really nice mindset of you're not moving data around, you're just trying to process as much data in situ as possible. So if you've got something like a pandas data frame over here, it will just simply use the existing pandas data frame. It's not going to move things around. And this is why it becomes really, really great for this kind of analytic function. If you've got some data in R or in a C class or whatever, DuckDB is just going to simply just squizzle some pointers out under the covers, which makes it really, really lightning fast. And I'll show you what that looks like. And it's really, really extensible. As an active project, it's got a bunch of existing things like connecting off to S3 or Parquet files or full text searches and geospatial, so it's really quite extensible. So, like I said, I'm hoping people walk away and get somewhat motivated tonight. It's really straightforward. If you're on a Mac, you basically say brew install DuckDB and you're golden. If you're in the Python world, you pip install it. If you're in the NPM world, I don't understand NPM, but apparently this is what you do. But at the end of the day, it is very, very straightforward to install, get it running, and suddenly it's in process and you're up and alive. So that's DuckDB, and now we've got our things in S3. Let's talk about how you actually glue that together. So this is pretty much the statements I can run on my laptop. I fire up DuckDB. I say, bring in the extensions so I can talk to S3. I set my S3 credentials and my region, and I say, select star from bucket with a glob at the end. And basically, that's all I'm doing. So I'm just going to say this again. I've written some SQL. I've put the path to my bucket. I've put a star at the end. And that's all I needed to do. And now I'm talking SQL on top of external Parquet files. And I just think that that's so magic. And I think that's really cool. But it gets cooler than that, which I'll get to. Because it's actually SQL, I can do all of the SQL things. I can create tables, and I can do analytic functions, and I can do all of that good stuff. So I've got my I ran this for a week or so. I ended up harvesting 1.6 million messages over several thousand Parquet files. They're sitting in my bucket. Does anyone want to guess how long this statement takes to run? 1.6 million messages, several thousand Parquet files.
I don't want to get something to ask. What's the advantage of working directly with S3 package versus cross input?
Sorry, I missed the
What's
question.
the difference between first doing the import of data to a database versus directly working with one?
So the question is, what's the advantage of pulling it in?
Working with a packet directly.
Can you say, maybe we could hold that question to the end? Okay, because I had the question. I'm asking the questions. How long does this take? How many seconds do you reckon that takes to bring in
2 seconds.
2 seconds. Close. 0.8 of a second. So it takes 0.8 of a second to pull all of those distributed Parquet files in and 1.6 million things. Sorry?
How fast is the internet?
Yeah, well, this happened to be sitting on the same instance. But anyway, the takeaway here is it's very fast.
Is it really cataloged in all the package file and process for it, or just
Yeah, these are all just Parquet files sitting in a bucket, just tearing them all up, shoving them into memory, creating a table.
What's the average size of the file?
I don't know. I'm going to share some stats at the end. So, okay. This was the moment where you went, ooh, so fast. Okay. Tough crowd. Right, data and analytics. So this is the other really, really cool thing. Not only is it great to harvest the data in, it's very, very straightforward to then start using the data. So you can do something like this. Like I said, I lifted in millions of toots, and I kind of just wanted to do some really basic things like what's the most frequent user, what is the distribution over time, and all of that kind of stuff. So you can basically just write rudimentary SQL and do modes and medians and some case statements and that kind of stuff, and you can start seeing this kind of stuff. So generally finding that I was seeing about 200,000 toots a day from 50,000 unique users, and initially I was seeing about 4,000 servers, but over time it sort of grew. I was actually starting to see about 10,000 servers towards the end. The most frequent host was Mastodon's social, and it just seems that news organizations are the biggest producers of messages. There's also like like some flags to indicate if you're a server or a news organization. It seems that most news organizations don't honor that, so they're not actually playing by the rules of the API. Anyway, so that's basic Mastodon usage things, just using SQL. But what I really wanted to do was, who's like a Python user? If I say the words data frame, do you know what I mean? Cool. So you can use this syntax within a notebook. So I'm using just double SQL syntax. You can use this double chevron thing to say, run this SQL statement, but instead of showing the display, barrel it into a data frame. And I think that's really cool, because then you can go, well, from that data frame, just do some plots. So I can run that SQL, barrel it into a data frame, do a plot, and it does that. And again, I think that that's kind of super neat, because I'm just typing SQL. SQL is reading the Parquet file. It's barreling it into a data frame. It's actually doing a lot of abstractions for me. And from that data frame, I can just start visualizing stuff. And again, I think that's really, really neat. So the takeaway here is I'm looking at things like, well, what is the most frequent app used for people using Mastodon? Turns out that most Mastodon users are using the web for writing their snarky toots, but things like Aubury and Moa and Tusky seem to be quite popular apps. The web usage is preferred, but there's a whole bunch of apps that are coming more frequent. And another thing I noticed in all of this is that the app attribute tends to not be federated across instances. So I found I could only scrape that directly from instances. When messages were transported to another instance, it tended to lose the client ID, which is just a side observation. Toot length by language usage. Again, I'm using this syntax of, well, let's start looking at the language that people are actually tooting in. And I started just sort of graphing, or what across languages, what's the, sort of the mean, median, and the essentially density of the toots that people are using. And I found that maybe this is surprising or non-surprising, but sort of Chinese, Japanese, and Korean toots tend to be shorter than English toots. Gaelic and Finnish messages are longer. Don't take this as gospel, but my theory here is that logarithmic languages like Mandarin convey more in fewer characters. So it was just a bit of an observation, but I did just find it interesting. This is sort of amortized across millions of messages. It's just kind of interesting to see that sort of language density show up. And then I was curious around, well, that's sort of the standard size toot, which is 140 characters. When people toot and they get really, really irate, how big do their toots get? Does anyone want to guess the biggest toot I saw in a week? 68,000 characters. So yeah, the API allows you to write crazy big toots. And I didn't realize this, but I had to go and, yes?
By any chance, do you have what was it that it tweeted for 68,000?
I do have to show. Anyway, it turns out this guy just tooted this character 68,000 times. And because I'm old and I didn't know, I actually had to ask my children what that is, but apparently that's Marzi the cat. It's like one of the things I had to look up on Know Your Meme because I'm out of touch. Anyway, so 68,000 pictures of that cute little guy. Cool. Some surprising statistics in doing all of this. So this is taken from 10 days worth of data from Feb 3 to 12. I saw 1.6 million toots. I saw 142,000 unique users, 8,300 unique instances, and that seemed to be growing. I saw 131 unique languages, which is kind of interesting. The shortest toot was 0 characters. I'm not sure what they're saying. You saw the longest toot, but the average was 151 characters, which is kind of close to like a tweet. Of all those toots, 245 million characters over 1.6 million toots, shoving that in memory into DuckDB takes up 740 megabytes. So DuckDB is really, really efficient. Okay, another class participation activity. How long does it take DuckDB to calculate all of those numbers?
2 seconds.
Close.
Yes.
It actually took 0.7 seconds to calculate all of that. So again, when things are loaded into memory, it's really fast. Yes?
The languages, how does it calculate the languages? Is that a rule or is it a flag? Or?
Oh, it's a good question. So the question was, where does the language attribute come from? It actually comes from the client. So I assume it's part of the operating system that carries it across, and sometimes it's set correctly and sometimes it's not. Yes?
So fitting this question, you mentioned the app does not federate code.
Yes.
So does it come as blind or does it come as web?
Yeah, so the question was, does the client federate? It comes as, actually, stupid observation in all of this. The Python library, when you listen to the public feed versus the private feed, is a different class type, and the class of app designator is not there if you listen to the public feed. If you turn on private feed, it actually puts it there. So I'm assuming it's not federated, but the class it provides is slightly different. Right, what else am I going to do? Oh, does anyone have time for a quick demo of DuckDB? Yeah, cool. If you're interested, there is a version of a blog. You can play with all of the code. If you want these slides, which has the links to all of those things, grab that QR code now. Or you could probably just Google random guy playing with Mastodon and Kafka and stuff like that. Has everyone got that question?
It seems to be like unbelievably quick and pretty efficient. Is there anything that it like trips on and it's like really not good at? Or
Yes, when it runs out of memory. It fails spectacularly when you run out of memory. But maybe I can show you what it's good at and what it's not good at in just a second. Can I move on? Oh, yeah, you call for a demo? Yeah.
So that's it's all in memory.
It's all in memory. If it doesn't fit in memory, yeah, out of luck.
So does it just refuse to start?
Yeah, it just gives you like sort of weird error, which is not very helpful. You asked before, that was the longest toot. I can scroll it through if you want to.
No, I'm good.
Fine. So for convenience, I'm just doing this in a notebook. But you can just do this with the CLI. So you can just do some import DuckDB. I'm going to run everything in memory and just do some basic decoration. install the extension so I can talk S3. Actually, I'm not going to do this. I'm just going to run it on local disk. So I've got I'm going to cheat here because I've taken everything and just shoved it in a local Parquet file, but just to give you a bit of a sense. So this is a file on disk. It's a Parquet file, and I can just use this syntax to just say, read it, you worry about the data types, you worry about the headers and all of that. It's all in the Parquet file, and I can just say select star from it, which is kind of neat. Okay. So what I actually want to do is, now you've seen that this is kind of like how I'm capturing it. It's got these things like, the URL, the base language is kind of encoded, so it's like that ISO thing, so EN, FR, PT, Polish, maybe? Portuguese, yeah. Username, and then the blurb of the text. So I'm taking all of that, and I kind of go, okay, well, my goal now is I kind of want to take all of that. I want to take the language and convert it. So I've got just a basic little lookup of, ISO code to pretty language name. So I'm going to read that in, and then I'm going to take the epoch is just number of seconds since 1970. So I kind of want to make that a proper date. You're texting my brain asking a question halfway through, didn't you?
Does it persist only as a script or as data as well?
So I'm happy.
Does it persist as a script or you can save data as well?
Oh, you can save data as well, yeah. So you can say create table. In fact, that's what I'm about to do, so good question. So I'm actually going to say create table as all of this stuff, and then create table as the join of my language table to this. I'm doing some regular expressions. I'm going to do this time with 2 million rows. Anyone want to guess how long this is going to take? I think this is...
2 seconds. 2 seconds.
Oh.
1 second.
2 hours.
Oh, 1.1 seconds. 1.1 seconds to take in 2.8 million records. Again, this is kind of that's kind of fast. Fine. Tough crowd. So I've just gone and created my table called Mastodon Toots. And I can do all of this kind of thing, like, number of users, all of that kind of stuff. This is the cool syntax. So I can take a query, take it into a data frame. Why is this taking so long? Okay. And then I can do Seaborn, basically, to take that data frame there and do pretty visualization stuff. That longest toot thing, so common to the CTE, analytic function, go read 2 million toots, find me the longest one, 2.6 seconds, language used, take all of the text, shove it into a data frame, that kind of stuff. So I'm not going to go through all of this. You can play with the notebook yourself. But I kind of just wanted to leave you with the takeaway that this is super powerful. You've got basically this full SQL dialect. You can shove things into data frames. You can query from data frames. You can mix and match. I'm using data frames here. The same thing works with C++ files and R. I don't understand R, so I can't demo it. But it's really, really neat that you've got this sort of powerful SQL technology, and it's sort of abstracting away a lot of powerful stuff under the covers. And did I mention it's super fast? So with that, I just wanted to say thank you. Question?
So it's super fast. But I want to know, do you have any enterprise applications?
So the question was, are there any enterprise applications?
Yeah. I'm using this in the company.
I wouldn't put this into like some sort of pipeline. I wouldn't go and say I'm going to get rid of Oracle and replace it with DuckDB. But maybe if I could answer a different question, I am using this in my day job. So quite often I'm on sites that wouldn't allow me to take all of their sensitive data and shove it up into the cloud, so I can just shove it in Databricks or something. Having this on my desktop means I can do all of that kind of query stuff. I think 5 years ago I might have been writing like a quick awk script or something. Who's old enough to know awk? Anyway, but I do use this in my day job when I've got sensitive data and it's here and I'm not allowed to move it to a cloud. And I'm looking at this going, well, it's good enough for private data warehouse. Question?
So just want to share a story of mine where I use this in a job interview. Because when I was given a laptop on campus, but there wasn't any PostgreSQL to install on it. So I wanted to do some analysis of the dot. And I couldn't remember the correct syntax to save my life. So I just installed a PPA right now for SQL.
That is such a good story. And kind of very, very similar here, that I think I'm much faster with SQL than knowing the equivalent in pandas. Like I need the top 10 or the most frequent thing. I know that in my sleep, SQL. So to be able to do that on top of the pandas data frame, it's pretty cool. Yeah.
So you're saying that this is not going to kill the cloud data warehouse. There's just some local applications that you've sort of taken us through, like yourself, being able to run SQL on files. What other use cases do you see, what have you seen out in the wild, or what do you envision as a result of the capability that brings?
Yeah, so sometimes if you Google the words DuckDB use cases, people always go, oh, well, it's a SQL-like killer. And there's some crazy claim that there are something like 100 billion SQL-like databases. It's in like every IoT device out there. So sometimes people are talking about DuckDB as a replacement for SQLite. Now, I wouldn't actually say that, but I would say that it's quite realistic to think about. There's a lot of stuff at the edge or in other non-traditional places where you do want to do a lot of analytic processing in a web browser, as part of your C++ app, in your Node application, and the fact that you've got the power of SQL, this crazy fast in-memory stuff, all of the extensions, and you can just add it to your existing app, I think opens up a bunch of applications. So I keep thinking about this is me, a human, using it, but I think there will be a lot of applications where it's essentially embedded into another application. So wherever there's a bunch of edge processing or discrete processing requirements in some other language, I think that's going to be a good use case.
Yeah, I was just going to ask that if you're working with like so much larger APIs, does it work well to use fixed predicate instead of actually get this smaller subset?
I guess I haven't had enough experience really to work that out. I know there's the classic problem that you've got like thousands of Parquet files and halfway through the schema's changed. And one of the recent changes with that Parquet reader was you could do a union all across. So as it's reading different Parquet files and there's a sort of a mutation or a schema change, it will smartly, it won't append, it will actually smartly just go, oh, okay, I'm going to add these columns and all these columns. So there's, that was a long way of saying, yes, you can use big Parquet files, or you can use a large variety of Parquet files, and the recent releases are much more elegant at handling almost like a variety of data encoding schema representation in these Parquet files. Oh well, you saw it was a screen.
Just on a similar, if DuckDB being used for like serverless data processing, for instance, like say you've got a whole bunch of Parquet files in an S3 bucket. Instead of using glue job, you might just kind of have DuckDB in a Lambda function with a lot of memory, and you just kind of copy, I don't know, an aggregate or some sort of database process instead of reaching glue or Databricks or something like that.
Yeah. And again, it's not going to solve every single problem. I had a real-world problem the other day where I needed to take in gobs of Parquet files and JSON files, and I was using DuckDB for that. And then I needed to process a bunch of XML files, and DuckDB does not understand XML files, so I just had to write some shoddy Python to change it into JSON. So it ain't going to solve everything. Does anyone? If you had a bunch of XML files, what would you use these days? What do the cool kids use? Okay.
Yeah, XML to JSON.
Yeah.
It's like,
Yeah.
it's a good graph.
Yeah. Cool. So yeah, anyway, it's a new project, it's a fast-changing project, but I reckon it's one of those projects that's worth keeping an eye on and just worth getting familiar with. Oh, one more.
If you are using orders, it's standard SQL context.
Sorry?
Orders.
I'm not familiar with that. Can you explain?
It's basically, it's very similar to pandas, but it's really fast.
Okay.
So it actually is a couple of orders much faster and
I'm going to say maybe exercise for readers. I am familiar with, ultimately it's essentially a wrapper around Arrow, and it would not surprise, as long as it's kind of like some sort of variant of Arrow, someone's probably wishing an extension. One of the things I want to play with is some of the R extensions, which are apparently quite cool, but I'm just not as familiar with R. So I'm going to say it wouldn't surprise me if it's on their roadmap map, as long as it's a fairly modern sort of wrapper. Cool. With that, thank you.
So,